So on example 1, we have angle A and we have angle C. Looking at our properties, we don't know anything concerning angle A and angle C. What we do know about the angles is that the opposite angles B and D are equal to each other. The other thing that we know is that in a quadrilateral, all quadrilaterals have 360 degrees in them. Think about a square. They're all 90 degrees. You have 4 angles, so there's 360 degrees total. So we have 360 degrees total. Right now, we are using up 85 plus 43 of them. So right now we're using up 128 degrees total. So that means that we have 232 degrees left for angles B and D together. They are equal to one another. So they have the same value. So if we divide that 232 by 2, we get 116 degrees for each of these angles. Check it to make sure. Add them all up. 85 plus 116 plus 43 plus 116. It should equal or total 360, and it does. Okay, let's look at number 2. If we look at that kite right there, let's see here. I believe J and L should have the same measurement. Those angles should have the same measurement. So J, 82 degrees, and then we have 3 out of the 4.
Lobby 7, we have a counterpart from 701, Lobby 7, 701.
So 82 plus 82 plus 71. Right now we're using up 235 degrees. So that means that we have 360 minus 235. We have 125 degrees remaining for angle K. Let's look at number 5. We've got a bunch of angle measures that we need to figure out. A key here is going to be the right angle in the middle. So when we find the measure of angle 1, we have a little triangle right here. We have a little right triangle. So 180 minus 90 is 90. So 90 minus the 65 is 25. So we've got 25 degrees here for angle 1. Let's see here. Let's go back up to our properties. The diagonals are perpendicular, but I believe that the diagonals also bisect each other. So if angle 1 is 25, then angle 2 is also 25 degrees. Angle 3 is there in the middle. It's a right angle. It's 90 degrees. The measure of angle 4 is congruent to the 65 degrees that was given in the problem. Let's see here. Let me label what I've got on here for 65. The measure of angle 7 is 52. So for 5 and 6, those are the remaining, they're equal to each other, they're the same angle, and those are the angles that we have left in our quadrilateral. So when we add up all the exterior angles here, they equal, or they should equal 360. We don't have them all yet. We've got 25 plus 65 plus 52 plus 52 plus 65 plus 25. So right now we have 284 degrees, but we need to take that away from 360. And that leaves us with 76. 76 is the total of 5 and 6 together, but they're the same angle. So if we divide that by 2, we get 38 degrees for each of those. Okay, number 6 is going to be very, very similar to that. So let's see here. Measure of angle 1, it is the same as that 46 degrees. The measure of angle 2, well, we've got a right triangle right here. We've got a right angle and 46 degrees, so we have 190 plus 46 is 136. So take that away from the 180 that's in the triangle. We've got 44 left for angle 2. Angle 3 is congruent. Angle 4 is a right angle there in the middle of the kite. Angle 5 is congruent to the 73 degrees. And let's see here, 6 and 7. We've got to do what we did there at the end. We need to add up everything that we've got so far. So we have 2 73s, we've got 2 46s, and we have 2 44s. Okay, 44 with 2 and 3, 1 at angle 1 and 46 degrees. We've got 2 of those. Angle 5 and 73 degrees. We have 2 of those. So we have 326 so far. So 360 minus 326 leaves us with 34 degrees for both 6 and 7. They are congruent to one another, so we divide by 2. So those are both 17 degrees. Okay, let's look at some lengths. Okay, stepping away from angles for a minute, let's look at lengths. WX is 14. WR is 8. They want us to find RZ. Okay, well, RZ is not a part of the triangle right here, which is what we're going to focus on. So I'm going to pull it out. We've got 14, we've got 8. I added the right angle because those diagonals are perpendicular. We need to use our Pythagorean theorem right here. We're missing that length. So x squared plus 8 squared equals 14 squared. 14 is our hypotenuse. So we subtract 8 squared. Square root both sides. So we get that x is equal to approximately 11.5. So that's right here. RZ, those diagonal, or that diagonal is cut in half. Okay, now the long one from W to Y is not cut in half, and it's pretty clear in the picture. But the short one from X to Z is cut in half. So 11.5 RZ is equal to, well, approximately 11.5 because we rounded. Okay, let's look at number 8. If AC is 38, so from here to here is 38. From E to D is 41. Find CD. So we've got another little right triangle going on here. I'm going to draw it. I'm going to change its orientation just a little bit. Here's E, here's C, here's D. So we've got 41 here. We know from A to C is 38. We just talked about the fact that that is cut, that diagonal, that short diagonal is bisected. So if we divide it by 2, we've got 19 from E to C, halfway there. This is another Pythagorean theorem, but this time we are looking for the hypotenuse. So leg squared plus leg squared equals hypotenuse squared. We don't have to move anything to the other side. We just square root both sides. 19 squared plus 41 squared. We get 45.2 is approximately our x. And that was what we were looking for. CD is x right here. So 45.2 is our answer. And we should make sure that that makes sense. The hypotenuse should be the longest leg, so it is longer than that long leg of 41. Okay, back to the angle game for a minute here. Solve for x. We have angles at A and C labeled and at D labeled with 109. What I'm going to do is I'm going to automatically write down what I know. I know that B is also 109 degrees. So I have all four angles in my quadrilateral labeled here. So since it's a quadrilateral, all my sides added together equal 360. Just like you can do with a triangle with 180, all the sides in a quadrilateral add to 360. So let's look. Like terms, 3x plus 5x is 8x. We need to add all those constants together. So 109 plus the 8 plus 109 plus 14. We've got 240. Then we're solving for x. Subtract 240. 8x is equal to, that should be 120. Let me double check. Yep. And then we divide by 8. X equals 15. Was that what our problem was asking for? Go back to the beginning, solve for x. So yes, we are finished. Okay, let's look at number 14. Find the measure of angle STV. STV. So we're wanting this angle right down here. Nothing is labeled around that angle. Let's look at what is labeled. I see a right triangle up here. So when we add all of our angles together, plus 90, don't forget that 90, don't forget that right angle. It's a triangle, so those are equal to 180. So like terms, 9x plus 23x is 32x. 1 minus 7 plus 90 is 84. Subtract 84 from both sides. 32x is equal to 96. Divide by 32. X is equal to 3. Not looking for x here, we're looking for STV. STV is congruent to the 9x plus 1, so let's plug in 3. We get 28, and those two angles are equal to one another. All right, couple more. Number 15, find the measure of angle FGJ. FGJ. So we're wanting this angle right here, obviously not labeled again. What is labeled are these two angles, which are the bisected pieces of F. So they are equal to one another. So when we solve this, 3x minus 1 is equal to 11. Add 1 to both sides. 3x is equal to 12. Divide by 3. X is equal to 4. We're not looking for x. We are wanting that angle. Now, that angle is not equal to either of the angles that we have, but it is a part of a triangle with the angle 2x plus 11. So let's plug in our 4. 2 times 4 plus 11. 8 plus 11, that's 19. So the angle up there at the top is 19. So when we take 180, subtract the right angle of 90, subtract the 19 degree angle, that leaves us with 71 degrees for the angle we're actually looking for. All right, one more. Find the measure of angle NQP. NQP. So we're looking for this entire angle down here at Q. We know that half of it is 4x minus 7. We don't know about the other half. Obviously, it's the same expression, but you can't set it equal to itself. Okay, so what other information do they give us? Well, they give us the other angle of this right triangle, because 4x minus 7 is really both of these. So if we add 4x minus 7 plus the 11x minus 23 plus 90. Those are the three angles from that triangle. They should equal 180. So 4x plus 11x, 15x. Negative 7 minus 23 is negative 30 plus 90 is 60. So we subtract the 60. 15x is equal to 120. Divide by 15. X equals 8. We're not looking for x. We want NQP. Half of NQP is 4 times x minus 7. So that's 32 minus 7, which is 25. That's only half of it. So we've got to double it. The entire angle there at Q is 15.